average rate of change, I have a picture here. I pulled this picture from the textbook, and there's just some curve function f, probably part of some polynomial. And I have 2 points marked here. There's like, this is at x sub 1, and this is at some other x sub 2. And I want to know about the average rate of change between those 2 points. Now, when you think about rate of change that you have studied before, you talked about rate of change a lot with linear functions because they have a constant rate of change. It's their slope, right? So you would put 1 point and then you could go up 2 over 1, up 2 over 1, and it was always the same. You can see in this curve that sometimes the slope is higher than it is at other places, like where that maximum happens, it's probably slowing down and you're not going up as far as you would have normally. So it doesn't have a constant rate of change, and that's true for any nonlinear function that's not a line. It doesn't always stay the same. So when we want to do the average rate of change, basically what we're doing is we're picking 2 points on a nonlinear graph, and we're going to find the slope of the line that goes through those 2 points and call that the average rate of change. Okay, so today you are relearning slope, but it's not for a line, it's for a nonlinear function. So you should say, today will be easy. There's a definition for average rate of change that I would recommend putting in your notebook, and if you want to draw a picture of what average rate of change really means, that's what I would draw. A curved graph with 2 points and a line in between them. And the average rate of change will be the slope of the line through any 2 points of a nonlinear graph. If it's linear, it's not an average rate of change, it's the rate of change, because it stays constant. In calculus, you'll spend a lot of time figuring out how to evaluate the slope at any given point. And that's where people start talking about derivatives and things in calculus. Yes. So when we say, because we're calling it the average rate of change, it's not the rate of change. The rate of change is no longer constant like it was for linear. Well, you can take the average of a set of numbers that are very different. And an average is just kind of like a measure of central tendency. So we're trying to get to the center of the slopes, but there are going to be some that are higher than our average, and there are going to be some that are lower. There are going to be some that maybe are equal to our average. Yeah, that's going to happen. You'll be told which points. Okay, in a problem. So this is the notation that you'll see in the textbook. Don't be alarmed by that the numerator, f of x sub 2 minus f of x sub 1. Remember that f of x is just a fancy way to write y. So what this numerator really says is y sub 2 minus y sub 1. Does that look familiar? Yeah, look. So again, we're not actually calculating the rate of change because it changes, but we're just getting 2 points on a function, and the book will tell us which 2 points. Okay, and you will calculate the slope between those 2 points. In my own words, just really quickly, that formula amounts to the change in y over the change in x, and that correlates right back to our warm-up and some of those questions about writing equations of y. So you're just going to calculate the change in y over the change in x. So here's what your examples in the textbook will read like, so that you're kind of familiar with, when you get the directions, what they're actually asking. Okay? It'll say something like this. Find the average rate of change of f of x equals x cubed minus 3x So they'll give you the function, and in this case it's a cubic function. It could be any kind of function that is nonlinear. And then they're going to say from x sub 1 equals negative 2 to x sub 2 equals negative 1. So they're now telling you which 2 points to use. The only information that you don't have is the y value. Can you find the y value at those two x's? Plug it in. So for this first one, x sub 1 equals negative 2, I'm going to do f of negative 2. And I'm just substituting negative 2 in everywhere as the x. So f of negative 2 is equal to, this is negative 8 and then plus 6. So it's equal to negative 2. And I now know the x and the y. X sub 1, y sub 1. Both are negative 2. And then I've got to do it again for x sub 2 equals negative 1. So I got to do f of negative 1. Negative 1 cubed minus 3 times negative 1. Whatever function you're given, plug in the x value to get your y. This is what? Negative 1 plus 3. So f of negative 1 is equal to 2. Now what I have right there are really two ordered pairs. If it helps you out, remember this is like your x, it's the thing you plugged in. So this is like my x sub 1, and then this is my y sub 1. This is my x sub 2, and this is my y sub 2. I'm getting them as ordered pairs in function notation. And so the last step you'll do is once you find the x and the y values, calculate average rate of change. I just used ARC as my abbreviation for that. So I'm going to do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that would be what? 4 over 1 or just 4?
Or the numbers x's or y?
The number you plugged in was x sub 1. The number you got out is y. Yeah, so this is a y. And then this is x sub 2, and this is the y sub 2. So it seems a little bit weird because we're using that function notation, but what I want you to concentrate on is you're really just figuring 2 points, an x and a y, and then you're calculating the slope. That's the average rate of change. Are there any other questions? Yes, sir.
Would you always do that, or would you already know that it's negative 2?
How would you already know that it was negative 2?
Well, I thought it was like the same as if you plugged it, because you got negative 2 to answer it, and you plugged it.
No, it won't always, because like on this one I plugged in negative 1 and I got out 2. So it doesn't always come out to be the same thing. You'd actually have to plug it in and do the order of operations. Anything else? Okay, so just really quickly, your homework, and remember that your homework is always on your gold sheet. So if you want to pull your gold sheet out right now, for your homework today, it should say these 3 things. It should say, watch the piecewise video. It's going to be posted on my website. I'll show you how to get there in just a moment. These 2 problems from page 57 is what we just went over. So these are average rate of change. Okay, so you have 2 problems of average rate of change. And then the other 2 problems are piecewise functions. okay, which is what you'll do after you watch the video. The video is like 15 minutes long. So total, I'd say homework this weekend probably takes you like 30 minutes. The easiest way to get to my website, it's on your syllabus, it's above the clock right there. Come up. It's to go to Papillion Literacy South, go to academics, click math. You'll get to this page, pick my name. When you get here, I used to have more than just honors pre-calculus, so you have to click honors pre-calculus. And then it will take you here. At the very top here are all the files. So I posted like yesterday's notes, and I'll post today's notes there as well. And then here are the videos. So I haven't posted today's video yet, but I will add a link there for average rate of change, so if you need to rewatch it, you can. And then here's video notes 1.6. It says due Monday, August 21st. Then you just click that, and it'll be the 15-minute video. Okay. Also, if you're ever like at home and you don't have your gold sheet, the gold sheet is at the bottom of the page. So you have all the things. The other thing to note is that on the gold sheet, it says that there's a library of functions due, or basic functions due on Monday. You can change that to Tuesday. Monday's going to be Eclipse Day, so we're all just going to be really flexible about what happens on Monday, okay, in terms of time and what we get done. So I'm not going to ask that this library function be due on Monday. I'll say due Tuesday. Most of this you can fill out from prior knowledge in your math class. There are a couple of things that you don't need to worry about on the theme sheet. You can write due Tuesday above it if you want. You do not have to worry about that last column that says odd, even, or neither. We're going to go over that hopefully on Monday. And then on the back side, where your name is not, greatest integer function, you do not yet know. So we are going to talk about that on Tuesday. So if you want to wait to fill in greatest integer function, you can.